Good morning again. We're now doing lesson 104. You should have already checked your homework. Again, making note of any questions you might have. On lesson 104, we're on page 674. As we turn there, we're going to be talking about arc lengths and chord. And we have a new theorem. We haven't had a theorem in a while. We have a new theorem here. But let's review real quickly what we're going to be talking about. A type of angle who has its vertex at the center, its vertex at the center, is a central angle. A central angle is congruent to the arc it intercepts. So if the arc is 50 degrees, then the angle is 50 degrees. Keep that in mind. That's different from our inscribed angle, which is half of the intercepted arc, But let's look at our theorem 104, which is on page 674. All right, it says in the same or congruent circles. Most of the time they're typically giving it to us in the same circle, but it could be in two separate circles that were congruent. But in the same or congruent circles, congruent arcs have congruent chords. Congruent arcs have congruent chords. So if my arcs AB, remember a minor arc has two letters underneath the arc symbol, is congruent to arc CD, then these chords here are congruent. The chords that go from the endpoints of the arcs are congruent. That means segment AB is congruent to segment CD. In the same or congruent circles, congruent arcs means that we have congruent chords. We've already proven again with central angles and their chords, central angles and their arcs, but we're now looking at arcs and their chords. The second part of this is simply the converse. If I have congruent chords, then my arcs that they intercept here are congruent. That if I'm given the chords being congruent, then my arcs there that they intercept here, that they form, are congruent. You'll look at it in your book on page 675. You'll see a chart summarizing what we have learned. We have four main things here that go together here. First off, if we have congruent central angles, then we have congruent chords. Congruent central angles, then we have congruent chords. So if I have congruent angles, central angles that is, then I have congruent chords. Again, that they are intercepting, that those central angles are intercepting. Those chords that are at the mouth here of our central angle. The second one, if I have congruent arcs, then I have congruent central angles. If I have congruent arcs, then I have congruent central angles. So this time, if I'm given the arcs here are congruent, then these angles are congruent. We know their measures are the same, so proving that we've already done before. If this was 50 degrees, the angle would be 50. This arc was 50 because it's congruent. This central angle has to be congruent to that intercepted arc, and if the arcs are the same, then therefore the angles are the same. So we have central angles, then congruent chords. Congruent arcs, then congruent central angles. It's going to keep on circling around here. If I have congruent chords, then I have congruent arcs. So now this time we're given these chords. If I have congruent chords, then these arcs here, where the endpoints intercept, are congruent. If I have congruent chords, then congruent arcs. Congruent central angles, congruent chords. Congruent arcs, congruent central angles. Congruent chords, congruent arcs. And lastly, if I have congruent arcs, then I have congruent chords. If I have congruent arcs, then I have congruent chords. And you can see how these keep circling right back around to each other. No pun intended since we're dealing with circles. But if I have congruent central angles, congruent chords. Congruent arcs, then I have congruent central angles. If I have congruent chords, then I have congruent arcs. If I have congruent arcs, then I have congruent chords. Let's look at your examples here in your book on page 676. Let's look at example A. Solving for x here. I have congruent chords. Their intercepted arcs that they form, therefore, must be congruent. If they're congruent, then their values must be the same. So I simply need to set these two equal to each other. 14x plus 28 equals 19x plus 3. I'm then going to simply do basic algebra here. Solving for x. X equals 5. X equals 5. If they wanted me to actually find the actual arc value here, the actual degrees for it, I simply need to plug that back in, which this does ask for me to do. I plug that 5 in, and I have 19 times 5 plus 3, which gives me 98 degrees. Not the bad 90s band. 14 times 5 plus 28 gives me 98 degrees as well. Let's look at example B. It's a proof. We haven't done a proof in a while, so it'd be good to stretch ourselves a little bit. We're proving the end part of 104.1, so I can't use 104.1. All right, let me get you started on this one. First thing is our given, that these two are congruent to each other. Our next step, obviously, hopefully, is that AB, AC, and CD, AD are all congruent to each other. That's because they're radii in a circle, and radii in a circle are all congruent. All right. What's always king? Triangles are king. Triangles are king here. We're going to prove congruent triangles. We're going to be able to prove this by side, side, side. We've proven all three sides and those triangles are congruent. So triangle ABC is congruent to triangle ACD. If we have congruent triangles, then the next step, hopefully we're not rusty on this, then the next step is simply that we can state that these angles here, I'm going to number my angles. Angle 1 is congruent to angle 2, and that's by CPCTC. Congruent parts of congruent triangles are congruent. Finally, if I have congruent central angles, which we've proven, then the arcs that they intercept are congruent. Arc BC is congruent to arc CD, and that's because the central angles are congruent. The central angles are congruent. All right, let's go ahead and let you get started on your homework. Have a great weekend and a great rest of your day.